The electric vehicle market is experiencing a surge in popularity. However, a significant hurdle remains: affordability. For EVs to achieve widespread adoption, their prices need to be comparable to gasoline-powered vehicles. This is where innovations in manufacturing, particularly in battery technology and vehicle construction, become crucial. Reducing production costs is key to making EVs accessible to the mass market. Tesla, the current leader in the EV market, has demonstrated that profitability in the EV sector is achievable. Tesla's success in the EV market stems from its unique approach to both technology and business. Unlike traditional automakers, Tesla has embraced vertical integration, controlling most aspects of production, from battery manufacturing to software development. This allows Tesla to optimize efficiency and reduce costs across the board. Furthermore, Tesla's focus on innovation extends beyond the vehicles themselves. The company has invested heavily in developing new manufacturing techniques, such as Gigacasting, that challenge conventional automotive production methods. This commitment to streamlining manufacturing processes has enabled Tesla to produce EVs more efficiently and cost-effectively than its competitors. Tesla's profitability, a rarity in the EV market, can be attributed to this combination of factors: vertical integration, technological innovation, and a relentless drive to optimize manufacturing. Gigacasting represents a paradigm shift in automotive manufacturing. This innovative technology is changing the way cars are built, making the process more efficient and cost-effective. By utilizing large casting machines, manufacturers can now produce significant sections of a car's body in a single piece, which was previously unimaginable. Traditionally, car frames are assembled from numerous smaller parts, a complex and labor-intensive process. Each part must be individually manufactured, inspected, and then meticulously assembled. This not only takes a considerable amount of time but also increases the chances of errors and inconsistencies. The traditional method requires a large workforce and a significant amount of resources, making it both time-consuming and expensive. Gigacasting, as the name suggests, involves casting large sections of the car body as single pieces, significantly reducing the number of components and simplifying assembly. This method allows for the creation of larger, more complex parts that are stronger and lighter than those made using traditional methods. By reducing the number of parts, manufacturers can streamline the assembly process, leading to faster production times and lower costs. Tesla, at the forefront of this revolution, employs gigacasting to produce the front and rear underbody structures of its Model Y. This approach not only enhances the structural integrity of the vehicle, but also reduces its overall weight, improving performance and efficiency. Tesla's use of gigacasting is a testament to the company's commitment to innovation and its drive to push the boundaries of automotive manufacturing. These massive aluminum castings, produced by the world's largest casting machines, replace dozens of individual parts, leading to a lighter, stronger, and more cost-effective vehicle structure. The use of aluminum also offers additional benefits, such as improved corrosion resistance and better energy absorption in the event of a collision. This results in a safer and more durable vehicle that can withstand the rigors of everyday use. This innovative approach to manufacturing offers numerous advantages, from reduced weight and increased structural rigidity, to simplified assembly and lower production costs. By minimizing the number of parts, manufacturers can reduce the complexity of the supply chain, leading to fewer delays and a more efficient production process. Additionally, the increased structural rigidity enhances the vehicle's handling and performance, providing a better driving experience for consumers. By streamlining the manufacturing process, Gigacasting has the potential to transform the automotive industry, making EVs more affordable and accessible to the masses. This technology not only reduces production costs but also shortens the time it takes to bring new models to market. As a result, consumers can expect to see a wider variety of electric vehicles available at more competitive prices. The adoption of gigacasting is a significant step forward in the quest for sustainable and efficient automotive manufacturing, paving the way for a future where electric vehicles are the norm rather than the exception. The gigacasting process begins with molten aluminum, heated to extreme temperatures. This aluminum is melted in large furnaces, reaching temperatures over 700 degrees Celsius. The intense heat transforms solid aluminum into a glowing molten state, ready for the next stage of the process. This molten metal is then injected at high pressure into massive molds, specifically designed to create the desired vehicle structure. The injection process is critical, as it ensures that the molten aluminum fills every nook and cranny of the mold, capturing even the most intricate details of the design. These molds, often weighing several tons, are precision engineered to ensure the final casting meets the exact specifications. The molds are crafted with meticulous attention to detail, using advanced computer-aided design (SAD) software to achieve the perfect shape and dimensions. This precision is crucial for the structural integrity and performance of the final product. Once the molten aluminum fills the mold, it rapidly cools and solidifies. The cooling process is carefully controlled to prevent any defects or weaknesses in the casting. As the aluminum cools, it transitions from a liquid to a solid state, forming a robust and durable structure. The resulting megacasting, a single massive piece of aluminum, is then extracted from the mold. This extraction process requires precision and care to avoid damaging the casting. Factory workers, often assisted by advanced machinery, carefully remove the casting and prepare it for the next stages of production. Advanced robotic systems are employed throughout the process, from handling the molten metal to extracting and transporting the finished castings. These robots are programmed to perform their tasks with high accuracy and efficiency, reducing the risk of human error and increasing the overall productivity of the manufacturing process. This process, while seemingly straightforward, requires sophisticated technology and precise control over various parameters, such as temperature, pressure, and cooling rates. Each parameter must be meticulously monitored and adjusted to ensure the quality and consistency of the castings. The use of advanced sensors and control systems allows for real-time adjustments, maintaining optimal conditions throughout the process. The success of gigacasting lies in the ability to consistently produce high-quality, complex castings that meet the stringent demands of automotive manufacturing. These castings form the backbone of modern vehicles, providing the necessary strength and durability, while also allowing for innovative designs and features. The gigacasting process represents a significant advancement in manufacturing technology, enabling the production of larger and more complex components with unprecedented efficiency and precision. Gigacasting offers a compelling array of advantages over traditional car manufacturing methods. This innovative technique involves creating large, single-piece castings for significant sections of a vehicle's structure, replacing the need for numerous smaller parts that must be individually manufactured and assembled. By reducing the number of parts and simplifying assembly, gigacasting contributes to significant cost savings, a crucial factor in making EVs more affordable. Traditional car manufacturing involves thousands of individual components, each requiring its own production line, quality checks, and assembly steps. Gigacasting consolidates many of these parts into a single large piece, drastically cutting down on the complexity and cost of production. The use of large aluminum castings also results in lighter vehicles, compared to those assembled from numerous steel parts. Aluminum is not only lighter, but also offers excellent strength-to-weight ratio, which is essential for maintaining vehicle integrity while reducing overall weight. This reduction in weight is particularly beneficial for electric vehicles, as it directly impacts their performance and efficiency. This weight reduction translates into improved energy efficiency, allowing EVs to travel further on a single charge. A lighter vehicle requires less energy to move, which means that the battery can last longer, extending the range of the vehicle. This is a significant advantage for consumers as it reduces the frequency of charging stops and enhances the overall driving experience. Furthermore, the inherent strength of aluminum castings enhances vehicle safety by creating a more robust structure. In crash tests, vehicles with aluminum castings have shown to absorb and dissipate impact forces more effectively than traditional steel frames. This not only protects the occupants better, but also reduces the extent of damage to the vehicle, potentially lowering repair costs. Beyond the immediate benefits of cost reduction and weight savings, gigacasting also simplifies the manufacturing process, making it more efficient and less labor-intensive. The automation of the casting process means that fewer human interventions are required, reducing the likelihood of errors and increasing the consistency of the final product. This efficiency translates into faster production times and the ability to scale up manufacturing to meet growing demand. This streamlined approach to production has the potential to revolutionize the automotive industry, paving the way for more affordable and sustainable transportation solutions. As more manufacturers adopt Gigacasting technology, we can expect to see a significant shift in how vehicles are designed and built, leading to a new era of innovation in the automotive sector. The combination of cost savings, improved efficiency, and enhanced vehicle performance makes Gigacasting a game changer for the